So first we're just looking at our original unbalanced equation. So here it is written out. So basically the equation is saying that when copper chloride and sodium nitrate, and that's the 2 there is for the 2 is the oxidation number. So when copper chloride reacts with sodium nitrate, copper nitrate and sodium chloride are formed. So that's the basic question, and that's just showing the reactants and the products and those colors. The colors. So the question is asking if 15 grams of copper to nitrate react with 20 grams of sodium nitrate, how much of the sodium chloride is going to be formed? And also we need to know the limiting reagent in this process and also what compound we have in excess of. So we're basically working with 15 grams of the copper nitrate from the original equation, and then so our given is 15 and 20, and our wanted is sodium chloride. So our first step, as always, is to balance the equation. So first I'm just going to write down the unbalanced equation from the original problem. And then I'm just going to write down right under each element how many of that element, how many atoms and molecules of that element there are. So you can see I have 1 copper, 1 sodium, 2 nitrates, and I'm dividing it by way to make sure that the number in the reactants is equal to the number in the products. So I have 1 nitrate on one side and 2 nitrates on the other side, so I need to fix that. I have 1 chlorine on one side and 2 on the other side. I need to fix that. So I'm adding a 2 to that sodium chloride, so there can be 2 chlorides like on the other side, 2 chlorines. And then now I still need 2 sodiums. So now now I'm just going to fix the numbers on the bottom to make sure they're all equal. We have 2 chlorides on both sides, 2 sodiums on both sides, 2 nitrates on both sides. There's 2 there and 2 with the coefficient there. And then 1 copper, so that's all done balancing. So our next step is to write down all the molar masses of each molecule or compound from the balanced equation on a separate sheet of paper, so you can just have it by you and reference it whenever you need it during your calculations. So for that, so for example, if the equation has sodium chloride on the product side, you need to add up the mass of sodium found on the periodic table, then the mass of chlorine, and add them together using a calculator. So I'm just going to do that for each little compound from the equation. So there's copper chloride. There's 2 chlorine atoms and 1 copper. So I found the masses on the periodic table and I'm adding them up. And that's going to be in grams because atomic mass is done in grams, or molar mass, sorry, molar mass. So for this part, to find the limiting reagent, we basically first have to change the number of copper chloride that we were given, 15 grams, into moles. So I'm putting grams at the bottom, and I'm using the molar mass found in the periodic table and on my sheet. And I'm putting 1 mole at the top because 1 mole has that many grams. Then I divided using my calculator and got 0.11 moles of copper chloride. And that number is actually how much of copper chloride that we have in storage. So now that I'm just writing that to the side so we can look at that, so that's 0.11 moles of copper chloride. And now I'm just doing this exact same thing with the sodium nitrate. So remember that we originally were given 20 grams of sodium nitrate, and I am just using the molar mass sheet, and I'm putting grams at the bottom. That gives me 0.24 moles of sodium nitrate. Basically, I just converted that into moles. So that is how much we have. So both of those values are how much of each compound that we have. So it's not, so when we find a limiting reagent, we of course want to find out what molecule we have more than we need of. That means that's an excess, and the one we don't have enough of is the limiting reagent. So now we need to find out how many of each copper chloride and sodium nitrate we need. So I'm using the 0.11 moles of copper chloride, which is actually, I wrote it wrong at first, so copper chloride. And I'm using the ratio from the original equation, so you can see that there's 2 on the left side of the arrow sign. There's 2 sodium nitrates for every 1 copper chloride, and I'm putting the copper chloride at the bottom so it can cancel out. So you always use a ratio of the coefficients from the equation, and I got 0.22 moles of sodium nitrate. So it's basically multiplying by 2 dividing by 1, 0.1. And then I'm just changing that back to grams. Just something you probably should do. If the problem gave you grams, you should probably go back to grams. So I just did that. So that's how much we need of the sodium nitrate. Just remember your sig figs. So 0.22 moles is equal to 18.7 grams. So we need 0.22 moles of sodium nitrate, or 18.7 grams, whichever one you want to use. And we don't need to find how much we need of the other copper chloride, because we can just compare with sodium nitrate to see if it's an excess or if it is limiting. So we need 0.22 moles of sodium nitrate, and we have 0.24. So obviously we have more than we need, so that's an excess. So we have that in excess. So that means that the copper chloride is the limiting reagent. You can also do that with the grams. We need 18.7 grams, and we were given 20 grams. So we have an excess of 1.3 grams. Or point, and you can do the same thing, subtract. So you know that the excess is 0.02 moles, or 1.3 grams. So now we know that the sodium nitrate is in excess, so that means that the other reactant will have to be the limiting reagent. That's going to be the copper chloride is going to run out first. So now that we have the limiting reagent, the excess, we still need to find the number of sodium chloride in grams and moles, because it's always good to have both. So pick any reactant. So the two reactants are the copper chloride and the sodium nitrate, CuCl2 and NaNO3. So I just picked the CuCl2, so 0.11 moles of copper chloride. And to find the number of sodium chloride, we're going to use the ratios from the original equation again. So the original equation said, we can just look at that in a second. The original equation had 2 sodium chlorides for every 1 copper chloride. You can see that there's 1 of copper chloride on the left side and 2 of sodium chloride on the right side. So we're just using basic ratios, and we put copper chloride on the bottom so that it can cancel out. And we get 0.22 moles of sodium chloride. So that's 0.22 moles of sodium chloride, and I'm just changing that back to grams. So basically what we are going to get is 0.22 moles of sodium chloride. And I'm just using the basic mole to gram conversion to find out that we're going to make 0.22 moles of sodium chloride, or 12.86 grams.